Hello, welcome back. In this video, we are going to learn about network topologies. So let's look at the agenda. We will be learning about network topology and then network topology types. What is a network topology? Network topology means the way that the nodes of a network are connected to each other in case of LAN. LAN means local area network. Local area network has a very small coverage area, that is either a room or a small building or a college campus. So it is limited within this small geographical area. Now, another important aspect of network topology is the number of ports that are required per node in the connection. Number of connections that are required in the network for data transmission. Whether collisions are there or not. What is the maintenance status? What is the cost of maintenance as well as cost of installation of the entire network topology? Then comes performance. So with respect to all these parameters, let us now learn about the different network topology types. What are the network topology types? We have mesh topology, then we have ring topology. After that, we will learn about bus topology, then tree topology. After that, star topology, line topology, and hybrid topology. Let's learn them one by one. Now, what is a mesh topology? Here in this figure, we can see that a mesh topology means the nodes are connected to each other. Here we have 6 nodes, N1, N2, N3, N4, N5, and N6. So 6 nodes are connected to each other and each node is connected to all other nodes. So here, since there are N is equal to 6, that means the number of nodes is 6. So how many ports are required per node? It is N minus 1 equal to, so it is equal to 5. And how many dedicated connections are there? N into N minus 1 by 2. So it comes out to be 6 into 5 by 2 equal to 15. So 15 dedicated channels are there for data transmission from one node to the other node. So here we can see these are all the dedicated bidirectional channels. Now, this type of network topology has the advantage that it is very robust and collision is not there because all are dedicated channels. So this is the advantage. But the disadvantage is that, so here we write this is the advantage, and the disadvantage is that as N increases, cost of installation and maintenance also increases because total number of links is N into N minus 1 by 2, and if N increases, then the number of ports also increases and the number of dedicated links also increases. Now, this is an example of a fully connected mesh topology. We can also have partially connected mesh topology. In partially connected mesh topology, all the nodes are not connected to all other nodes. So this is an example of partially connected mesh topology. Let's say we have 5 nodes, and here this is an example where we can find that you see here node N1, N2, N3, N4 and N5. So all the nodes are not connected to all other nodes, but a single node may be connected to more than one node in the network. So this is an example of partially connected mesh network. Let's now turn our attention to ring topology. In ring topology, as we can see in this figure, shows a ring topology where we have N1, N2, N3, N4, N5, N6. 6 different nodes are connected to each other in the form of a ring. So one of the nodes will act as the monitoring node to start the operation. And when a data transfer takes place, a token is released. Token is released, and after the data transfer is over, then the token will be transferred to other stations for data transmission. Now there are 2 types of token releases. One is the early token release, and the next one is the delay token release. In early token release, the token is released immediately after data transmission takes place, and in delay token release, token is released when data transmission takes place and acknowledgement is received. So this type of network has the advantage that collision is minimized and it can be expanded. But the disadvantage is that if we want to add or remove stations, then complications may arise. And it is easy to install and maintain. So cost is also less. Next we come to bus topology. This is an example of bus topology. In bus topology, all the nodes are connected through a central backbone link. And these are known as the drop lines. So if we have n number of nodes, then n number of drop lines are there and one backbone link is there. So this is not bidirectional, and communication takes place through this backbone channel. But the problem is that if the backbone link is broken, then the entire network crashes down. Next we come to tree topology. In tree topology, the nodes are connected in the form of a tree. We can see that there is a root node, and from the root node, several child nodes are forked. So this is root node is at level 1. The first level child node is at level 2. And each child node can fork their another child nodes, like these are called the leaf nodes. So in this scenario, we can see there are 3 levels. Level 1 is the root node, level 2 is the first level child nodes, and level 3 is the second level child nodes, also called the leaf nodes. So the leaf nodes are the nodes at the top level of the tree. This is an example of star topology. In star topology, there is a central hub through which all communication take place to all other nodes that are connected to the central hub. But the problem is that if the central hub crashes down, then the entire data communication crashes. So this is again a problem. We can also have intelligent hub. Intelligent hubs have repeaters in them, and non-intelligent hubs are basically passive in nature and they are only useful for broadcasting. These intelligent hubs are also known as the active hubs. Next, we have the line topology. As we can see that line topology, all the nodes are connected to each other by a single line. So connection between N1 and N2 is via this link L12. Connection between N2 and N3 happens via the link L23 and so on. So it is not possible for node N1 to connect to node N3 directly. Rather, it has to pass through N2 and then to N3. Next, we have the hybrid topology. In hybrid topology, 2 different types of topologies can be used here. One ring topology is connected to one star topology through a central hub. So hybrid topology can have the advantages and disadvantages of the different topologies that are used to connect in the hybrid manner. Here I come to the end of this video. In this video we have learned about the different network topologies. We learned about tree topology. We learned about bus topology, ring topology, star topology, hybrid topology, and so on. And we also looked into the advantages and disadvantages of these topologies with respect to various parameters like cost, maintenance, then collision, number of ports, and number of connections required. Thank you.